So I'm Juliann Raikes, and my maiden name was Leny.
2011. She is a chemical engineer for the Dow Chemical Company. Her official title is Improvement Engineer, Process Safety First Focal Point. And she will tell you all anything you'd like to hear. So anytime you have questions, just raise your hand or just speak, and she will answer away.
Stop me anytime. So I just do have a few slides just to kind of get things started. They're really short, nothing crazy, but so I'm gonna share my screen here. Y'all can see everything right now. Sometimes Zoom and my computer don't get along because I'm on my work one, but I'm gonna go ahead into presentation mode. So like Julie said, I'm Juliann Raikes. I'm an improvement engineer, process safety focal point, and I graduated from Carroll in 2011. So about 9 years now. So just a really quick about me, because I wasn't sure if we were doing video or not, but so I did graduate from the University of Cincinnati in 2016 with a Bachelor's of Science in Chemical Engineering. And I've been, ever since I graduated from college, I've been an improvement engineer in our polyethylene production facility and CoOp Process Safety Focal Point since 2016. So I started there right out of college. And just for fun, outside of work, I enjoy traveling with my husband and family, reading, playing piano, and oil painting. And so we live in the New Orleans metro area with our two cats, Winston and Sterling, that you can see there. So I'm going to go into a little bit about, so I'm going to start, I guess, with what is a chemical engineer, because it's such a broad field to go into. And so I looked up the dictionary definition of it just for fun, and it's the science or profession of applying chemistry to industrial processes. Like very vague, very large kind of field of study to go into. And so I just kind of listed some of the industries that chemical engineers work in, because I'm in polymer science, I'm in plastics production right now, but there's just so many other areas that you can go into that I know classmates have gone into and some other colleagues. So there's industrial chemicals. So that's a lot of the basic building blocks for everything that we interact with on a daily basis. So cosmetics, food, the automotive industry, oil and gas, and pharmaceuticals. And I mean, that's just like some of the basic ones. It can be healthcare, a little bit more like medical science, all the way into a bit more like an automation, almost like computer engineering standpoint. If you get into like process automation, you can be a chemical engineer that does more like coding and computer work. So that's just a really, really quick sampling of what we can do as a chemical engineer. And then like what sort of settings do chemical engineers work in? I think the kind of stereotype is that you're working in a lab, but in reality you can be in manufacturing facilities like I am. So I work in like a lot of outdoors settings. So I'm outside a lot in the plant looking at pieces of equipment, et cetera. But you can be in a laboratory, an office setting if you're in a more like a design engineering role, and et cetera. So there's lots of different settings that you can work in as well. So really, if you go into this field, there's a lot of options on what you want to do as a career. It opens a lot of doors, and you're not working in just this one place if you're not interested in it. So a day in the life of an improvement engineer. So what do I do on a daily basis over the last 4 years? So I'm aligned to the gas phase polyethylene production facility in Honville, Louisiana. So that's about 45 minutes outside of New Orleans. So I actually live close to the city, but drive out to the plant for work because it's kind of in the bayou. So a lot of my day-to-day life and job focusing, I attend daily production meetings since I'm aligned to the plant to hear the current state of the plant and learn of any immediate issues that need addressing. So we have engineers who focus more on, what rates are our reactors running, what equipment's having problems, are we running the best that we can? So that is their main focus. But since I'm an improvement engineer, I've got a little bit more of a long-term focus for improvements in the plant. So I'm looking, instead of day to day or month to month, I'm looking for a 1 to 3 year outlook on how can we get better How can we get more efficient? How can we get safer? How can we get more environmentally friendly? Because we're always looking on ways to improve that as well. So what I do is I gather production data to determine where projects or efforts and studies are needed. So where are our opportunities to get better in one of those things? And then we take that data and that cost data to prioritize our projects and efforts based on either financial return or improvements to safety and product quality or in the environment. So we take all of that into account to prioritize what we're working on, because there's a lot of opportunities, but only so much, financial resources, personnel resources to get those things done. So we're always prioritizing based on where we're going to get the best return for our efforts. And then we scope out those projects and work with our design engineering resources to create packages for implementation. So, once we identify that we've got a problem or an opportunity, we work with our unit to understand, what do they need? Like what size equipment do they want? What do they want it to do? What do we need it to do? And then we have a design engineering team that's on our site that the plant improvement engineers work with to help communicate those requirements to our design engineering resources, and then kind of go back and forth in this process. They'll create a design, we'll review it, and make sure that things are going to function as intended and meet the needs of the plant. And then they create these design packages that we can then send out to either some internal construction resources, or we can go external if it's a larger project. Like one recently was, it was over $1 million project. So we went external to a different contractor. So they came in and they were like a specialized contractor who came in and did our project for us. So then when you're in that stage, then we are expected to oversee the construction of the projects in the unit. So we're walking out every day, seeing how the project progress is, and make sure that we're, keeping an eye out for any issues or some designs, because sometimes you have a design on paper and when you go to build it in the plant, something might be a little bit different than you expected. So you have to kind of make some changes on the fly as well. And then the most exciting part, in my opinion, and as always the most challenging, is you work with the production personnel to commission our new equipment safely. So you're working on making sure that you're doing all of your safety checks before you put everything in service, and then you start working on how you introduce the chemicals to the unit and then get it running and turn it over to operations. So that's a really quick high-level overview of kind of like the long-term improvement process as an improvement engineer, what we're working on. I mean, we're working on lots of small things in the unit as well, and helping out the production folks. Like if they're out, out on vacation or out sick, we can also step in to help make sure if there's issues going on in the plant, we can help troubleshoot as well, just to help support the plant wherever needed. It's just not our main focus. And then the other side of my role is process safety focal point. So myself and one of the other improvement engineers, she's a senior improvement engineer. She's been at one for about 8 years now in our plant. She and I help kind of lead studies on, worst case scenarios in the plant, because, everything in engineering, it's a lot of large equipment, and making sure that we are proposing and implementing protection layers to ensure it's the safe operation of the facility. And we also perform safety reviews on any changes that people want to make in the plant. So we're always looking at that to make sure that we're getting a second set of eyes, and we kind of act as the safety subject matter experts in the unit. So that's kind of like the other side of my role. It's usually an improvement engineer in the Dow facilities, but it can be any role. But it's kind of something that I have a passion for, because, you can have production, you can have a lot of production, but if you're not doing it safely, then it's not worth doing it. So process safety is a huge part of what I do. And then the last slide that I have is kind of just like my career path after Carol, just kind of how I got to where I am. And then I'll open it up for questions, whatever, if you guys want to hear more about school or, work, anything in between, I'm willing to answer. So my career path, so I graduated from Carroll in 2011. And then after the summer after I did that, I was a Wright Scholar at Wright Pet. So I worked in the Human Effectiveness Directorate for 2 summers. So the summer after I graduated, And then I also went back as a contractor outside of the Right Scholar program between my freshman and sophomore years of college before I started co-oping. So I did research for 2 summers on, we were doing stuff with DNA, aptamers, and gold nanoparticle conjugates, and we were using it to help identify like small molecules out in the field. So it was a lot of lab scale research. I worked with the folks in the human effectiveness directorate, lots of PhD chemists. It was really great experience on how to design experiments properly. And it was actually able to get a couple publications from the Right Scholar program. So I'm not sure if they're still doing that program. I think they are, but I would highly recommend if you're interested in working in some sort of STEM science engineering field. So I was able to do more chemistry based, but I know some folks who did more mechanical based as well at Right Pat. So the Right Scholar program is great. So I did that for 2 summers. And then in school, I started college in 2011 at the University of Cincinnati, and they have a 5-year program because of the co-op program. So I did 5 terms of co-op at Sabic Innovative Plastics in Evansville, Indiana. So if anybody's looked into UC yet, sorry if this is a bit of a redundant, but how UC's co-op program worked, at least when I was there, we went to school for a full 2 semesters freshman year, and then we had a summer off, so that's where I was working as a Right Scholar. And then starting fall of your sophomore year or second year, you are either co-oping or you're either at school. So even the summer semester, so I did an alternating co-op. So I co-opted in the fall, and then I went back to school in the spring, and then I co-opted in the summer, and then went back to school in the fall. So you do that for 3 years. So that's year 2, 3, and 4. And then your 5th year, you either are at school or co-oping for that last summer. And then you come back in the fall and do your last 2 semesters of senior year. So that's like your capstone and any classes that you're finishing up. So it's a total of a 5-year program, but I can't stress the value of co-op enough to being able to find a really great full-time position after college, especially in engineering, because I was able to get almost 2 years of experience as, you know, we did, because I was all at the same company, it was like a rotational program where I was able to go get experience in a bunch of different areas of being a chemical engineer at a manufacturing site. Like, even though I was at the same sites, I worked in site maintenance, I did some stuff in pilot plants. So that was a little bit of lab scale, a little bit of production scale. So it's kind of that in between, which I found very exciting. That's one of my favorite rotations I did, was when I was at the pilot plants, and then all the way up to full scale production facilities, which is where I am now with a different company. But I was in polycarbonate and polyether imide manufacturing. So I've been in polymers since I started in co-op. And then I graduated in 2016 as with a bachelor's in chemical engineering. And then I graduated in April, and I started in June with Dow down here in New Orleans as an improvement engineer at the polyethylene production facility. And that's where I've been ever since, getting lots of great experience, really enjoying working for Dow. They're a great company. But that's just a really quick about me and kind of how I got where I am. So I guess I can open it up for questions now.
I do have a question. Like, what type of classes would you suggest, especially for the high schoolers currently? Or for all classes, yeah. So, like what classes do you think would prepare you the most for your current career?
So for chemical engineering specifically, obviously chemistry, any chemistry you can take. So I did not take AP chemistry because I think it was fairly new when I started, or when I was going through Carroll, but I would definitely suggest any chemistry that you can would be a great class. Math is really important. So you do calculus. So in college, you know, your curriculum is very heavy in math, very heavy in physics, and very heavy in chemistry. So you're taking kind of, those are your 3 bread and butter kind of subjects that you're always working on. And then depending on which industry you want to get into. So I actually focused a bit at first on kind of like a biosciences area. So I did anatomy, I did biology, and that is definitely a viable career path as well, kind of getting into like that biochemical engineering. Because I know there is biomedical engineering, which is kind of like an offshoot of chemical and mechanical together, specifically focused on medicine. But you can also go into more of a biology focus, like pharmaceuticals is an offshoot of chemical engineering, but they appreciate a lot more of the organic chemistry, the biology, those kind of things. So it really depends on which industry you know, and it's okay to not know right now. I didn't know until, you know, as I was going through college, like what industry would be exciting for me. And, but the biggest ones, like I said, math, science, math, physics, chemistry are your three big ones. So but that's a lot of engineering is very like sharing, like mechanical does a lot of similar classes as us. We just take a lot more chemistry, and then they do a bit more complex math than we do.
So like, how do you apply that math, physics, chemistry that you learn in school, like on your day-to-day job?
Okay, yeah. So that's a really, really great question. So, you know, a lot of what I said before focused on, you know, the business side of things and that, but so the biggest thing about going to engineering school is that they almost like teach you how to think like an engineer. Like I always say it's like you get a toolbox, where college, you get a toolbox of equations that you can use, concepts to learn, and you learn how things work. And then when you get into, especially like where I work now and we're troubleshooting and nothing's exactly the same every time, you are able to use those toolboxes that you learn in college. So your equations of state, you know, the ideal gas law, to basically help constrain the problems that you're seeing and understand them better, and then use those fundamental principles to be like, oh, this is what's happening, this is what I can do to make it better. So, you know, PV equals nRT is an ideal state. You'll know, well, if my pressure is going up, then my temperature is going to go up, and then you can apply that basic concept. Obviously, reality is a bit more complicated than that, but you can at least get a really easy framework to understand what's going on in your process. So the biggest time that you use engineering fundamentals like that is during like project design. Obviously there's designers who do that, but you can really help gut check, okay, does this make sense? Does this make sense for what I know, how things work, for the design that they're giving me? And then troubleshooting. Troubleshooting is the other really big, you know, you've got something and you've got all this data and you don't know what's happening. Like, it's not doing what you think. Why is it not doing what you think? You take basically all those classes that you learned, and you learned about fluid dynamics and heat transfer, to, you just work through the things, you know, you can make theories. So that's kind of where those like fundamental science principles, the math, the fluid dynamics, the heat transfer, all of that, that's where that comes in, at least in my role. But if you're wanting a more, so I don't do calculus on a daily basis, if that's what you're getting at. But the folks who are a bit more in like the automation space and the design space, they do interact a bit more with the engineering fundamentals than, like, let's say I do a lot of business as well and financials. So there's a whole range of how much math and science that you do as a chemical engineer, and it really just depends on what role that you kind of go after when you graduate.
How did Carol help prepare you for your future?
So Carol has a really great math and science program, especially for, you know, as I said, that is your bread and butter for engineering. So that was the biggest thing that helped me prepare, was the fact that I was able to get, you know, calculus in senior year of high school, which was huge. That you can either test out of some calculus if you want. I decided to not do that and go ahead and just take calculus in college, but it was able, you know, stuff I was already familiar with, kind of get my feet wet in college because I was taking a lot of other classes. And then all the AP classes, so we were able to, like, physics was a lot of things that we had learned in physics at Carroll. So that was the biggest thing that helped me as an engineer. But also, I mean, we got a really wide range of other experiences. So I was like a drama club. I was the pit orchestra pianist for drama, and then you know, tennis and stuff. So it also had a lot of wide ranges of kind of making you a well-rounded person, you know, even outside of just the science and math. But for engineering specifically, it was the quality of the STEM classes.
Who or what inspired you to pursue your career?
So that's actually a really great question. So for a while, and actually up through college, I had kind of been deciding, do I want to be an engineer or do I actually want to go be a doctor? So those are the two kind of things that I was doing. And If that's something that you all are thinking about, you can do engineering, then also do pre-med. A lot of folks I know did do that. So, and the interest in engineering kind of actually started in AP Physics with Mrs. Fuhrer was my teacher at the time in AP Physics. Yes, she's a great teacher. So I really enjoyed physics way more than I thought I would at the time. So then I was like, maybe I need to start, because like I always liked biology and I always liked math. So then I got this like physics aspect, which is always a bit more the stereotypical engineer class. So I started looking into engineering, and that's how I signed up for that program. But I still always had in the back of my mind, like maybe I'll go into medicine and I'll be a doctor. So I did also take the prerequisite classes in college on top of my engineering courses, which it actually was only a couple of extra because chemical engineering has tons of overlap with pre-med. But then after my co-op, kind of decided that, I enjoy medicine, I enjoy that, but I also enjoy engineering has a great work-life balance that, where I'm able to, I work probably 9 hours a day and then I get every other Friday off. So it's like the work-life balance was, more what I was looking for in a career. And also it was a lot more rewarding than I was expecting. When you say you're making plastic, it may not sound as exciting, but once you actually get into it, it's really complicated and it's got a lot of exciting science problems to solve. But that's kind of how I went. It was like for a while I was back and forth, chemical engineering. I was a chemical engineer, but was I going to actually go into engineering or was I going to go to med school? So those were the kind of two options I was throwing around.
I guess, how did you build up like connections? And I remember you mentioning about like co-op, but like kind of like how did you get into that? How did you enter that? And how did you like enter the field and get where you are?
Yeah, so that's where, so the co-op program at UC is mandatory. So you have to co-op. So they have a really, really great, I'm also going to sound like I'm plugging UC. I loved UC. They have a really great network set up. So you have, the co-op program is mandatory. It's not mandatory at all schools. So they have a really great resources. So they have career fairs where they bring in companies that are looking for co-ops and you're able to go talk to them and try to get positions. And that's how I ended up getting my first initial co-op with SABIC. So I went to a career fair in the spring of my freshman year and got a position starting in the fall. And then because that site, some folks that I know actually co-op for multiple companies. They didn't stay with the same company every time. And you can actually, at UC, you can do a research co-op as well. You can do research with one of the professors for a semester. At least when I was there, it was a while ago, so I don't know if they've changed their rules. But basically, it was because of UC's networks that they have a really great relationship with a lot of companies, and they set up those resources. They have job boards that you can look for, but because it is mandatory, they have that framework in place to help you reach out to those companies. And then once I had that co-op experience, I was able to go. So actually, no, I interviewed with Dow we have career fairs for full-time as well. So I was able to take my resume from the co-op, and it has a lot of like real world engineering experience that you're able to get as a co-op, and then go to all these companies at that career fair, or companies out that didn't come to the career fair. You can be like, hey, I'm entry level, but I've got XYZ experience. It makes it way easier to have that conversation in that interview of like, here's what I can offer. Here's, I know what I'm getting into. So that's why anybody that I know personally who wants to go into engineering, I'm always recommending co-op. Like, it's invaluable. And it helps, like you were saying, build that network and kind of get your foot in the door in some fields. So.
Well, thank you so much, Juliann. Thank you
for having me. I was glad I was able to join because I live all the way in New Orleans. Usually I wouldn't be able to, I don't live around Dayton anymore. So I was actually able to call in. So this was nice to be able to do.
Yes, it's definitely the only advantage to having Corona around.
Yes.
Well, thank you so much.
Thanks for coming, guys, and good luck with the rest of your school and what you guys decide to want to do. So thanks for having me.
Thank you.
Bye.
Bye.